Dear students, welcome to the video hypothesis test type 1 and type 2 errors. Dear students, as you saw in the previous videos concerning hypothesis testing, we saw that conclusions are made from calculations based on a sample of observations. Consequently, there are two ways to reach an incorrect decision based on the results of calculating probabilities in hypothesis testing: a type 1 error and a type 2 error. The table shows how these errors arise. Now, as you see in the first row, if null hypothesis or HO is true and it is accepted, you have made a correct decision. But if HO is true and it is rejected, it is called type 1 error. In the second row, HO is false while it is accepted. So here type 2 error occurs. HO is false and it is rejected. Here correct decision has been made. Example number 1, a football referee uses the same coin for the coin toss at the start of every game he referees. Karam suspects the coin is biased towards heads. He decides to record the result of each coin toss for the next 16 matches and carry out a hypothesis test at a 5% level of significance. Part A, find the probability of a type 1 error and state what is meant by a type 1 error in this context. Part B, explain why a type 2 error is possible if there are 11 heads. Now consider this table. Here in this row you have the number of heads, probability of x greater or equal to h. Y greater or equal to, as you saw in the previous video, this direction follows always your alternative hypothesis. Now probability of getting 16 heads or more, it's here, greater than 15 or more is 0.0003. Probability of 14 heads or more, 0.0021. 13 is here, 12 and 11. As you see here, probability of x greater or equal to 12 is 0.384. It is actually 3.84%, which is less than 5% significance level given in the question. So it means that 12 is in rejection region. Probability of x greater or equal to 11 is 10.51%, which is more than 5% level of significance. It means that 12 is critical value. It means that if you have 12 heads or more, you will make a conclusion that this coin is actually biased towards heads. And type 1 error here means that you saw in the previous part, type 1 error occurs that HO is true while it is rejected. It means that you decide that this coin is biased while it is not biased and it is fair. Part B says, explain why a type 2 error is possible if there are 11 heads. We learned that if you have 11 or more heads, the probability is 10.5%, which is more than 5% level of significance. It means that it is in acceptance region. So HO will be accepted. Now HO is accepted. If HO is accepted and it is false, then type 2 error will occur. Example number 2, a blood test is used to determine the level X of a certain protein to determine if a patient has a specific condition. X is abnormally high for people with this condition. Records kept over a long period show that for patients with this condition, X has normal distribution with 22 as mean and variance 7 squared, whereas for people without this condition, X has normal distribution with mean 10 and 3 squared as variance. Part A, in a screening test, a doctor decides that anyone with x greater than 17 has the condition. If the null hypothesis is a person tested doesn't have the condition, state the alternative hypothesis and the critical region, and find the probability of the occurrence of first a type 1 error, 2 a type 2 error. Part B, find the range of values of x such that the probability that the test doesn't correctly identify a person who has the condition is less than 0.03. Part C, find the value of x where the probability of a type 1 error is equal to the probability of a type 2 error. Now, HO, as the question says, a person tested doesn't have the condition. So H1 alternative will be a person tested has the condition. Now, so as the question says, the doctor decides that anyone with x greater than 17 has the condition. So it means that if x is greater than 17, it means that the person has the condition. Then HO will be rejected. Now, part I, probability of type 1 error. So type 1 error will occur when HO is true while HO is rejected. Now, so when HO is true, it means that a person tested doesn't have the condition. People without a condition will have normal distribution with 10 and 3 squared, and it is rejected. So probability of rejection actually will occur when x is greater than 17. So we calculate probability of x greater than 17, which is equal to 1 minus probability of x less or equal to 17, which is 1 minus probability of x, we standardize it, minus 10 divided by 3 less or equal to 17 minus 10 over 3, which is 1 minus 5 of 2.333, giving you an answer of 1 minus 0.9902, which is 0.0098. Now, second part, probability of type 2 error. Type 2 error means that H1 is true, but HO is accepted. Now, H1 is true means that X will have the condition. So people with this condition will have normal distribution with 22 and 7 squared. So you are going to accept HO. HO will be accepted if x is less than 17, less or equal to 17. So probability of x less or equal to 17, which is equal to probability of x minus 22 divided by 7 less or equal to 17 minus 22 divided by 7, which is equal to 5 of negative 0.714, which is 1 minus 0.77623, giving you an answer of 0.238. Part B, find the range of values of x such that the probability that the test doesn't correctly identify a person who has the condition is less than 0.03. Now, so If x has the condition, so x has normal distribution with 22 and 7 squared. So probability of x is less or equal to a is to be less or equal to 0.03. Now it will be phi of a minus 22 over 7 is less than 0.03. Now corresponding to 0.03, as the area in phi region is less than half, it means that it's a negative number. It means that it's a negative number. So you have learned in normal distribution how to make it positive. So it means that a minus 22 over 7 should be less than negative 1.881, giving you an answer of a is less than 8.83. Part C, find the value of x where the probability of a type 1 error is equal to the probability of a type 2 error. Now part C, for type 1, we know that x has normal distribution with 10 and 3 squared, because for type 1 error HO is true. So when HO is true, it will have normal distribution with 10 and 3 squared. And for type 2 error, H1 is true, so it will have normal distribution with 22 and 7 squared. So for type 1, HO is true while it is rejected. So when do we reject HO? When x is greater than the x that we are looking for in this part. So in normal distribution table, the probability of greater will be 1 minus phi of x minus 10 over 3 is equal to, for type 2 error, actually HO is false, actually H1 is true, and HO is accepted. So it will be phi of x minus 22 over 7, which is equal to, after using the normal distribution table and simplifying, you will find x 13.6.